Hello, and welcome to the last day of chain rule. I hope you're ready. So before we start today's lesson, I want to add two more derivative rules to all the other ones you have. So the first one is for when you have some number raised to the x power. It's kind of like the when we had e to the x power, and that rule, which was kind of similar because when we had the derivative of e to the x, the derivative was just itself. So here it's kind of similar because we have if we started out with a to the x, the a to the x power is still there. We're just adding on this natural log of a, so that gets multiplied to the original. Okay, and then the other derivative rule I want to add on is the derivative of log base a of x. And last time we talked about how logs were basically just like natural logs, because if you remember the rule for natural log, the derivative was just 1 over x. And so you can kind of see that here as well. You see the 1 over x in the end part of the formula. It's just we're also multiplying by the natural log of a on the bottom. So we're kind of just expanding on rules that we already knew. Just adding or multiplying in that natural log of a, whatever a number is. So let's start with a real basic example. So y equals 2 to the x power. So for finding the derivative of it, y prime, it's just going to match the first rule. So my a number is 2. So this is just going to be the natural log of 2 times 2 to the x power for my derivative. And that's it. Natural log of 2, if you actually did it in the calculator, you get some decimal. It's just a constant at this point. Okay, let's try another one. So let's say we have 2 to the 3x power. Okay, so slightly more complicated because now our exponent is now 3x instead of just x, which really means this requires chain rule because, we're complicating the x part of it. Okay, so chain rule, if I were to do this, the inside would be the 3x, the outside would be 2 to the whatever power. Okay, so the derivative of the outside would be the natural log of 2 times 2 to the whatever power, and in this case it was the 3x. And then we're also going to multiply that by the derivative of the inside. The inside was 3x, so the derivative is going to be 3. So my final answer for my derivative is going to be 3 times natural log of 2 times 2 to the 3x power. Okay, for my next example, I want to do one with the log. So here, we are finding the derivative of log base 5 of cosine of x. And again, there's no parentheses written, but really, we're taking the log of cosine of x with the base of 5. So again, we would need chain rule here. So the inside would be the cosine of x, and the outside would be the log base 5 of the stuff. Okay, so using our new derivative rules for the logs, then the derivative of the outside would be 1 over the natural log of 5 times, and then instead of x, I have like the stuff in parentheses, which for us would be the cosine of x. And then we'd need to multiply this by the derivative of the inside, and the inside was cosine of x, so the derivative would be negative sine x. Okay, so multiplying this out, we're going to get negative sine x on top, natural log of 5 times cosine x on the bottom. Nothing crazy there to simplify. That's it. Okay, let's get a little bit more complicated again. So this time I've got f of x equals log base 3 of the square root of x divided by x plus 5. Ugh. However, it's logs. Remember, we have log properties, so we can rewrite this. If I have stuff that's dividing, I can split this up into more logs, but subtract them instead. So I'm going to rewrite this into log base 3 of the square root of x minus the log base 3 of x plus 5. And notice how I put the x plus 5 in parentheses here, because if I didn't put the x plus 5 in parentheses, it would then look like me just writing log base 3 of x, and then the plus 5 is like a constant being added. So those are different things, so can't do that. So keep it in the parentheses, which also gives me a clue into I should probably use the chain rule because of the parentheses. I'm actually going to keep rewriting that first part though, because the log base 3 of square root of x, remember, you know me by now. We don't like the radicals, so I'm going to rewrite this with an exponent of 1/2. But then one of the log properties is that we can move the exponent to the front. So now we're just multiplying by a constant of 1/2, which is much nicer. Okay, so from here, I can use my derivative rules to find the derivative of that first part, the half log base 3 of x. So the constant multiplier of 1/2 would stay there. Log base 3 of x, there's no chain rule needed because it's just a regular x there. When I use the formula, the a would be 3. So this would end up being 1 over natural log of 3 times x. Okay, and then I have the minus, and then now I can find the derivative of the second half of my function. So here I'm going to need the chain rule because I got those parentheses. So the inside is going to be the x plus 5, and the outside is going to be the log base 3 of the stuff. Okay, so from there, let's find the derivative using the chain rule. So the derivative of the outside is going to be that 1 over natural log of 3 times the stuff instead of x, which was x plus 5. And then that gets multiplied by the derivative of the inside, where the inside was x plus 5, so the derivative is just 1. Not bad. So let me just simplify this a little bit and write it nicer. So this just ends up being 1 over 2 natural log of 3 times x minus 1 over natural log of 3 times x plus 5. And that's it. Okay, so I feel like we've got a good handle on those two new rules. So from here, this is going to be the craziest part. We're going to do what I like to call double chain rule. Insane. Here we go. So the equation we're going to use is y equals sine raised to the 5th power of 2x. Okay, the reason why we need double chain rule here is because if I were to rewrite this so that it looks a little bit nicer for you, it actually looks like this. I'm really taking the sine of 2x and I'm raising all of that to the 5th power. That's what that exponent of 5, when we write it in the middle, like right after the sign, that's what that means. So if it's written like this, do you see how we have like 2 sets of parentheses? Yeah, double chain rule. So I'm going to start with the first set of parentheses and label my outside inside. So the inside, with like the square bracket parentheses, I'm going to use the inside as sine of 2x, and so the outside would be like all of that stuff raised to the 5th power. Okay, so that's all fine and dandy for now, except my inside stuff has more outside inside. So for the sine of 2x, the inside is 2x, the outside is sine of that stuff. Okay, but then from there, that's it. So we have 2 sets of the outside insides because of the double chain rule. So when we find the derivative, all we're going to do is find the derivative of the outside, multiply it by the next derivative of the outside, then multiply it by the derivative of the last inside. So it's kind of like we just keep going. Before we just did derivative of the outside times derivative of the inside, we just have more things to do now. So I'm going to start here. Derivative of this outside is going to be 5 stuff in the parentheses raised to the 4th power. Okay, the stuff in the parentheses, the inside of it was the sine 2x. That's what was inside of it before, right there. Okay, next I'm going to multiply that by the next outside, but the derivative of the next outside. So the next outside thing was sine of stuff, so the derivative would be cosine of stuff. But when we leave that inside part the same, it would be the inside that it was attached to, so the 2x. Okay, And then lastly, we're doing the derivative of the very inside, the last one, which was the 2x. So the derivative would just be 2. So my final answer, after simplifying and multiplying all my stuff out, it's going to end up being 10, because I can multiply the 5 and the 2 together, sine to the 4th of 2x, because that's this part here rewritten nicely, times cosine of 2x. And that's the double chain rule. It's not like crazy. We're not doing like anything too complicated. You just got to add that extra step in where we find one more outside inside. Let's do another one just in case. So I've got y equals cosine squared of x cubed. So let me again rewrite this. So just so it looks a little bit nicer for me, I'm really taking cosine of x cubed and squaring that. Okay, so let's identify my outside inside again. So my first inside, I'll deal with the cosine of x cubed. And the outside would be like all of that stuff being squared. Then my next set of outside inside, I've got x cubed inside the parentheses. The outside is the cosine of that stuff. Okay, so ready. Finding the derivative of the first outside. Because it's like the stuff squared, it'll be 2 times the stuff to the first power now when we drop the exponent, which is just itself. The stuff inside would be the cosine of x cubed. That's the inside stuff it was attached to. Okay. Next I'm going to multiply by the next derivative of the outside. The next outside was cosine of stuff. So cosine, the derivative is negative sine of that stuff. And the stuff that was in the parentheses, the inside, was the x cubed. And then finally, at the very end, I'm going to multiply by the derivative of the inside, which was the x cubed, so the derivative would be 3x squared. Okay, multiplying everything together, we're going to end up with negative 6x squared because of the 2 times the negative times the 3x squared. Then we have the cosine of x cubed, and then we have the sine of x cubed. And that's it. There you have it. You are ready to do double chain rule. And that's it for chain rule in general. This is the last video of chain rule. You've got it all. You can do it all. Thanks for watching. Bye.